Good morning, students. Good morning. Very good morning. Am I audible? Voice clear? Okay, so last lecture we have discussed up to which part? We have discussed the structural isomerism, chain, position, I think. These covered. Tell, up to which part last class we have discussed? Chain isomerism and position also done. Achha. Okay, position not started. Fine. So starting with the second one, which is position isomerism. Position isomerism. What's the meaning of position isomerism? Write down. Compounds having same molecular formula. Compounds having same molecular formula. Same functional group. Compounds having same molecular formula, same functional group. But different position of functional groups, or substituents or multiple bonds over same size of parent chain and side chain. Over same size of parent chain and side chain. Clear? Written? Compounds having same molecular formula, same functional group, but different position of functional group or substituents or multiple bonds, but what has to be same? Size of the parent chain and side chain. That has to be same. For example, here, first one. Think about them. First one. Are they chain isomers or not? Sorry, position isomers or not? Are they position isomers? Yes, because they have same size of the parent chain, which is 4. Multiple bond is at 1, multiple bond is at 2. So they are which isomer? position isomers. Second one, think about 1 2 2 3 1 3. ठीक है, now second one, 1 and 2, 1 and 3, very good. The student who has said is 1 3. कौन है भाई ये? बाबा गंजापल्ली. अरे यार ये स्टूडेंट कौन सा है? Tanuj Kumar is there. Okay, good. 1 and 2, they are position isomers. Why? On the parent chain of 5, the position of NH2 functional group is changing. Therefore, they are position. But if you go by which one? If you go by 2 and 3, yes, it is again position. But what about the first and third? Very good. They are same only. Good, good. 1 and 3 are same because both are pentane 2 amine. ठीक. Then try next question. Position isomers of dimethyl cyclohexane and also find for dimethyl benzene. Done. So here for dimethyl cyclohexane, one possibility dimethyl on same carbon, 1 1 dimethyl. Second possibility, change the position, 1 2 dimethyl. Change the position 1 3 and then 1 4. These are 4 structural isomers and which are position isomers. Clear? Then next one. In next one for dimethyl benzene, can we say also 4 or not? Can we say only 4 are there? Sudeshna, very good beta. Answer is correct. Tanuj Kumar, I think you are getting it. It's 4 first here. Very good. Hiranmay, good, good beta. 4 and 4. Yes, incorrect. Tanuj Kumar, wrong. 3 only. Very good. This structure in benzene is not possible. This structure in benzene is not possible. Right? Yes, all are getting, I think, that this structure is not possible in benzene. C5H11 Br is next one. Find the structural isomers of C5H11 Br. How many are the structural isomers C5H11Br? Write down the all possibilities. Firstly, with parent chain of 5. Then parent chain of 4 with branching. Then parent chain of 3 with 2 branching. Br can be at which position? Can be at first carbon here or there. Second carbon here or third carbon there. 3 possibilities with parent chain of 5, 3 possibilities. What about parent chain of 4? 1, 1. Br can be here and here. Second possibility here. Third possibility here and fourth possibility there. And then next one is clear. Total structure isomers 8. In practice notebook, you can write the structure also. 1 bromo, 3 parent chain, only 1, yes. 1 bromo, 2 bromo, 3 bromo, pentane. Then here 1 bromo, 2 bromo, and here it becomes 2 bromo like this. So write down the 8 structures in a practice notebook separately. Then write down the next isomerism, functional isomerism. Functional isomerism. Write down compounds having same molecular formula. Compounds having same molecular formula, but different functional groups present. Same molecular formula, but different functional groups present. Example, these two compounds, they have same molecular formula, 3 carbon, 3 carbon. 1 oxygen, 1 oxygen. Degree of unsaturation is 0. Here also 0. Means they have same number of hydrogen also. So finally both have same formula, but one is ether, other is alcohol. Therefore these are termed as functional isomers with respect to each other. Functional isomers with respect to each other. Clear? Second example, think about it. Think about second one also, then think about third one. In second one, again they are which isomers? Functional Y, ketone, acetone, and aldehyde. Clear? ठीक है. Point is formula should be same. Formula is same, different functional groups. Answer is functional isomer. In first case, we cannot take aldehyde because if you take aldehyde, it will be having 1 pi bond. Degree of unsaturation is 1. Definitely formula will not match. Formula has to match. Think about third, A, B and C. Compare A, B with A and B, B and C like this. A and B, A and C, B and C. Think about them. Which isomers are they? Are they still having functional isomers? First and second. 1, 2, 3, 4. 1, 2, 3, 4. Carbon atom 4. 2 oxygen. Both have degree of unsaturation 1. It means hydrogen will match. Answer is they are having same formula, but one is acid, other is not acid. Other is ester. Answer is A and B. Functional isomers. Clear? What about A and C? A and C. Yash saying A and C are not functional. Remaining students, Tanuj Kumar saying A and B. Fine. A and C and B and C tell. Other students also. A and C, A and C, A and C. हर कोई जाने. जल्दी बताओ. हाँ, Navya saying good, good. A, B, fine. Yeah, A and C not saying anyone. Only Yash is giving the answer. Remaining students, A and C, B and C are not functional. Why Yogi Vardhan? Yogi Vardhan, you are wrong, beta. Point is, they should be having same formula but different functional groups. If you observe here, okay, yes, you are right. I have done mistake. DU is not matching. DU is not matching. So what should I do now? I want one more oxygen. That one more oxygen can be. चेंज कर दे क्वेश्चन को. चेंज कर दे क्वेश्चन को. चेंज कर दिया क्वेश्चन को. 1 2 3 4. अब बताओ. Question is changed. Yes, Yogi Vardhan, you were right, but now I am right. देखो भाई, DU मैच हो रहा है ना. DU is matching, carbon is there same. It means they are what? They are the isomers. Now, which isomers that we can find? So B and A and C, same formula, but one is acid, other is not acid. Other has aldehyde and alcohol. Therefore, A and C are what? Functional isomers. ठीक है भाई, getting everyone? All getting? Now, next points we have to remember. Theoretical points that we use in the example solving. Following are considered as functional isomers, like alkyne and diene. Second, alcohol and phenol. Alcohol and phenol. Third, primary, secondary, and tertiary amines. They have same formula. One is alkyne, other is diene. Then they are functional isomers. Same formula, one alcohol, one phenol. They are functional isomers. Same formula, but one is primary, other is secondary, other one is tertiary. Then they are treated like functional isomers with respect to each other. Fourth, nitroalkane and alkyl nitrite. They are treated like functional isomers. Alkyl cyanide and alkyl isocyanides. These are considered as functional isomers. These are considered as functional isomers. These are considered as functional isomers. Clear? Important among them is second and third, or you can say first also. These are more important. Remaining are for material solving, understand. Remaining are for solving the all types of question given on the structural isomerism. For example, here. Think about them. Think about them first. 1, 2, 1, 3, 2, 3. Okay, getting it? 1 and 2, they have same formula, but one is diene, other is alkyne. Answer is they are treated like functional isomers. Clear? Second one, first and third. First and third same. Alkyne and diene, functional isomers. Second and third, they are positional isomers. Good, beta, good. Tanuj Kumar, correct? Yes, good, good. Very good, Yogi Vardhan. All are functional. Nahi, Sudesh, na only. All, maybe you are seeing previous one, I think. Clear? Now try fifth one. Find for them. Done. अब check करो answer. In fifth, first and second, they both are phenols, but the side chain has one ethyl, other has side chain dimethyl. Parent chain same, size of the side chain is changing. They are chain isomers. Clear? First and second. Why? One is dimethyl, other is not dimethyl, other is ethyl. Then first and third. First and third, they are position isomers. Position of dimethyl is changing. First and fourth, now they are functional isomers. Good, good, Sudeshna, good. 2 and 3, second and third, again chain. Third and fourth, phenol and alcohol, functional. Clear? Next one. First is primary, second one is secondary. They have same formula, but one is primary, secondary. We treat them like functional isomers. 1 and 3, primary and tertiary. Functional isomers, 1 and 4. 1 and 4. 1 and 4. 1 and 4 is very good. Answer is they are positional isomers. Good, very good. Then 2 and 3, secondary and tertiary. Same formula, degree different, functional. 3 and 4, tertiary and primary, functional isomers. Clear? Done? Then next two, one is methyl nitrite, other is nitromethane. Both are treated like functional. Next one, methyl isocyanide, methyl cyanide. They are treated like functional isomers. Then next one is metamerism. Three and four नहीं यार 3 and 4 कहाँ से 3 and 4 Yash is asking beta 3 is tertiary and this is primary. Tertiary and primary same formula, they are treated like functional isomers. Clear Yash? Yash bhai gaming 3 not 3-1 क्या बात. Then next one, metamerism. Write down the meaning. Write down compounds having same molecular formula. Compounds having same molecular formula. Same functional group. Same functional group. But different alkyl chains. But different alkyl chain at either side of different alkyl chain at either side of polyvalent or bivalent functional group. But different nature of alkyl group at either side of polyvalent or bivalent functional group. Clear? Read it and then example. In this example, both are ethers, functional group same molecular formula, but with respect to polyvalent or bivalent functional group. Bivalent or polyvalent means like ether. Oxygen is both side bonded to carbon chain. That's a bivalent functional group. With respect to oxygen, here methyl and propyl, but on the first one it is ethyl and ethyl. So with respect to the bivalent group, the alkyl chain nature is changing. Therefore, they are termed as which isomers? They are termed as metamers, not chain isomers. So this isomerism arises when there is a bivalent functional group or there is a polyvalent functional group. Take so this example of metamers, or you can write which groups can be participating. Following can show metamerism. Like which one? Ethers, or ketones. Ketones में, if ketone metamer not given, then we can mark position also. Other is secondary amine, other is tertiary amine. Then thioethers, RSR, thioether. Anhydride can also participate. Ester तो भूल ही गया मैं, important. Ester. Anhydride, etc. possible. ठीक. These are the functional groups which are polyvalent functional groups. Ether example already I have given. Second example, suppose ketone. Check करते जाओ. Here both have same formula, both are ketones. Here with respect to ketone, both side ethyl, there is one side methyl, one side propyl. So ketones firstly treated like metamers. If metamers option not given, then go for position isomers. देखो भाई, third one, secondary amine, both are secondary amine, same formula, but the connectivity with respect to the polyvalent functional group or bivalent is changing. These are metamers. Tertiary amines, both are same degree, formula same, but connectivity is changing. So here they are metamers. In fifth, find out between 1, 2, 1, 3, 1, 4, then 2, 3, 2, 4. Find out 1, 2, 1, 3, 1, 4, 2, 3, 2, 4. Think about first and 5 also. हो गया completed? Very good, very good. Janvi, correct answer came. Srinivas Rao, correct. Janvi, correct. And Hiranmai, correct, beta. Very good. चलो लिखे आंसर 1-2 में both are esters. Yes. With respect to ester group, check here CH3, but here with respect to C double bond O, CH2 CH3. Alkyl chain is changing. That means which isomer? Metamer. 1-3. In 1 and 3, observe here. With respect to C double bond O, here we methyl, same. With respect to O, CH2 CH3, CH2 CH3. 1 and 3 are identical. Same. 1 and 4. What about 1 and 4? Tell. 1 and 4. Hiranmai has given the answer. 2 and 3. They are metamers. Correct, beta. 2 and 3. अरे नहीं यार. हाँ ठीक है ठीक है. 2 and 3 are metamers. Correct. What about 1 and 4? 1 and 4 are. 1 and 4 are. जल्दी बताओ. 1 and 4 का आंसर गलत मारा है. किसी ने मारा है गलत. यश ने दिया सही आंसर लग रहा है 1 and 4. नहीं भाई नहीं. तनुज सही पोजीशन नो. ऑब्जर्व हियर 1 and 4 ester, it is also ester. Understand one thing, it is C double bond O and H here. C double bond O R. This is the meaning of which functional group? Ester. Do not get confused with the H. Ester means COR. So here with respect to oxygen propyl and with respect to oxygen ethyl, answer is nature, functional group same, nature of the alkyl group is changing. Very good. What about 2 and 4? 2 and 4, again they are metamers. And what about 1 and 5? 1 and 5. Very good. 1 and 5 are functional isomers because first is ester, fifth is not ester. Simple thing. Clear? Then try other questions. Achha, before that, another is there. It's ring chain isomerism. Less important, but still solve or still understand. Ring chain isomerism. Write down compounds having same molecular formula. Same molecular formula. With one compound is open chain. With one compound is open chain and other is cyclic. One compound is open chain, other is cyclic. Other is cyclic. One compound open chain, other is cyclic. For example, these two. 4 carbon, 4 carbon. Du same means formula hydrogen same. One is open chain structure, other is cyclic structure, and in brackets you can mention in the definition they are considered as functional isomers. They are considered as functional isomers. They are considered as functional isomers. If ring chain not given, then we will mark them as functional isomers. Clear? Second example. Both have same formula. One is cyclic structure, other is a open chain structure. Try these questions. These are given in the NCERT in different chapters. Like structural isomers, find for C5H12O. It is given in the hydrocarbon. Some more addition I am writing. This is from the hydrocarbon. Third also hydrocarbon. Fourth, monohydric phenols. ठीक है भाई, ट्राई करो. These all are in the syllabus and in NCERT given. C5H12O in NCERT given. C5H12O. What's the degree of unsaturation? It is 0. If it is 0, C5H12O, du 0, it means you will clearly say no multiple bond, no ring structure. Now, what are the different functional groups you can consider? One possibility alcohol, second possibility ether. Okay, we cannot take aldehyde, du 0. Ketone gone. The options are what? Either alcohol or ketone, sorry, ether. So firstly consider alcohol structures. How many alcohols? How many alcohols you can write with C5H12O? Firstly, parent chain of 5, OH at different position. Second, parent chain of 4, one branching, OH at different position. And third, parent chain of 3 with double branching. Very good. Sudeshna got answer. 8th, 8. Very good. Yogi Vardhan getting 11. देखते हैं भाई कैसे आ गया 11. 1, 1, 2, 2, 3. It means with the parent chain of 5, you will get 3 structural isomer of alcohol. Then 1, 1, 1, 1, 2, 3, 4. So here 3, here 4, and here all at this position. Middle carbon already bonded to 4 carbon, not possible. So answer is 8 structural isomers of alcohol. Clear? Ethers with same formula. How many possibility? One is 2 and 3. है ना? In 2 and 3, one more possibility is changing in the connectivity. Again, structure change. Then 1 and 4, C5, 1 and 4, like this. Then 1 and 4 at which position? Second position, like this, sec butyl. Then any other possibility? Other possibility is there, like this. How many getting? 2 here. Then 1 carbon with 1, 2, 3, 4, 1, 2, 3, 4, and 1, 2, 3, 4. कितना आ रहा है भाई? मेरा तो आ रहा है ये 5. Check. Any other structure getting for ether? Check again. C5. अच्छा, एक और बनेगा यार, टर्शरी भी तो बन जाएगा, है ना? टर्शरी 6. Keep on trying. Main thing is, the more you practice by writing in the rough notebook, the better practice you are doing for the structural, the more you are able to write the answer. Clear? Try next one, C5H10. How many alkenes you can write? C5H10 only alkenes means already we know Du is 1. Either ring structure or either alkene, already given in the question, find out the alkenes possible. Done? How many getting? For next one, C5H10, how many alkenes? Good, good. Very good. 1, 2, 3, 4, 5. 1, 2, 3, 4. And like this. 5. Up. Where possible, double bond. It is possible between here and here. Okay. Then here and here. 2. There, what are the possibilities? Here and here. One possibility. Then here between them, second possibility. Then here, third possibility. 3 here. Here you cannot put anywhere double bond because there is no hydrogen. Carbon is bonded with other carbon. So here we cannot write. Answer is 5 structural isomers of C5H10. You can write with proper double bond to get more clarity. ठीक है? Then third one. Third one is which one? The fifth member of alkyne series. Tell me the formula of the compound. Fifth member of alkyne series. Then we can find now. Fifth member is, understand, Janvi. First member is not one carbon. First member of alkyne series starting with acetylene, which is ethyne. Tanuj Kumar asking, with ring, already in the question given in second one, C5H10 alkenes. So you cannot write ring structure because if you write the ring structure and double bond, Du becomes 2. Formula will never match. Very good, DSR, D. Srinivas Rao. First member is C2H2. Second member add CH2. C3H4. Third member C4H6. Fourth member C5H8 and fifth member C6H10. Homologous series na? C6 में how many possibilities you can write? One triple bond here, one here. Second there, and third there. 3 alkyne you can write with parent chain of 6. Now parent chain of 5 and branching. One branching here, one here. Can we write on these two? No. Triple bond cannot come here because carbon becomes pentavalent. Here also not possible. Here possible. Here possible. Can you draw here? Double bond here possible. Triple bond here not possible. Here and here not possible. Only one. Then with branching parent chain of 4. Here possible 1. Then can you write with alternate way? No. Not possible here. Clear? So here how many coming? 3, 2, 5, 2, 7. 7 are the structuralized. These are NCERT hydrocarbon chapter questions. Bhai, solid examples. Clear? Done. So the remaining questions you will try, or shall I give answer now? Or you will try ask in the next lecture. Na? Saturday also class there, yes. So you can ask in the next lecture about the other questions. Try them. Amines question there. Benzenoid, and keep the pages left. 2-3 pages left. You can practice more questions. And you can practice more questions, or you can add more questions as per the solving your material. These were the questions. You can take the image also, or take screenshot. Okay, leave 2 pages, 3 pages. But these are your notes. You understand. You add more questions. Clear? आगे बढ़े. ठीक है. अच्छा, if question is how many minimum C and H required to show position isomerism, or simple, how many minimum carbons required? Chalo, how many minimum carbons, not CS saying, only minimum carbons required for position isomerism. Minimum carbons required. Minimum carbon required to show PI. Answer is 2. Clear? Such type of questions you will get in the module also. Minimum carbon saying not only carbon and hydrogen. Clear? So that is the meaning of structural isomerism We have not discussed tautomerism. It will be part after the resonance. Now leave the 2-3 pages or 3 pages. Then write the geometrical isomerism. Geometrical isomerism. Start करें भाई. Geometrical. Write down the meaning also. Firstly, ready? Geometrical. It's a part of stereoisomerism. अरे भाई start करें. Good. Write down the definition. Compounds having same molecular formula, same structures. Same molecular formula, same structure. But different orientation of groups. But different orientation of groups. Different orientation of groups in space. In space due to restricted rotation. Due to restricted rotation. Due to restricted rotation. ठीक. So here write down the conditions to show GI. Achha, in the first lecture of organic, I told you about restricted rotation. Remember that in double bond, above the plane, the p orbitals are in locking, overlap, and below the plane. So carbon fragments cannot rotate freely. That was the meaning of restricted rotation. So today we are using that term, restricted rotation across different orientation of atoms or groups. So write down conditions to show GI. Conditions to show geometrical isomerism. First, there must be restricted rotation. There must be restricted rotation. There must be restricted rotation. That is which possibility? C double bond C or C double bond N. Important is ring structures, etc. Important is alkene example and ring structure. In NCERT, geometrical isomerism given on page 308 or old NCERT 386. As per your NCERT, you can mark that one. 2 pages are there. And then examples given on these pages are of alkenes only. So first condition is there must be restricted rotation like alkenes or ring structure or this other also possibility. Second point is at each end of restricted bond, there must be two different groups. There must be two different groups. Example, C double bond C. Here A, B, here C group, here D. Or here AB and here PQ. और ये सारी चेंज कर दी मैंने तो सपोज यहाँ पे P और A. ठीक है. So this is restricted rotation. On right end of the restricted bond, it has two different groups P and A. Left end also two different P, A and B. So this compound can show GI how its other isomer exists where here A, here A, here P, here B. A and A opposite. When similar groups on the opposite side, it is termed as which isomer? Trans isomer. And when similar groups on the same side, they are cis isomer, and the distance between those groups always change. Suppose it is x distance and it is y distance. So x will not be equal to y in cis and trans isomer. Distance always change between any two groups on each end of restricted bond in the two isomers. So here two different, here two different. If they are similar nature on same side cis, similar nature opposite side trans, and cis and trans isomers cannot interconvertible at room temperature. Because of restricted rotation, it cannot move like this, or therefore they will not be interconvertible at under normal conditions, non-interconvertible. Clear? Now apply these 2 points. Write down which of the following compounds can show geometrical isomerism. Can show geometrical isomerism. Which of the following compounds can show geometrical isomerism? Clear? Identify first 4. First one, GI possible. Think, put tick and cross. Put tick and cross for finding the correct answer. Among them, observe first one. In first one, if you observe, one carbon of double bond has two same hydrogen only. Cannot participate. Both sides should be not possible. Third possible, fourth not possible. Clear? So first has CH2, not possible. Second has CH2, not possible. Third has both carbon, two different. One here hydrogen, one methyl, two different. One hydrogen, one methyl, two different. This is transform written. In this, here CH2, double bond will not participate. Here CH2, double bond will not participate. ठीक है, चेक करो। फिफ्थ में यस पॉसिबल, सिक्स्थ पॉसिबल, सेवंथ पॉसिबल, एट्थ पॉसिबल। In fifth, terminal double bonds, they are not participating, but middle double bond satisfies the condition of restricted rotation and two different groups. Same way, sixth is a cis form. It is a geometrical center here. Seventh may no condition. Eighth may all four are different. Eighth, all four different, two here different, two here. Condition is on each end there must be two different. Getting it? Then ninth, 10th may apply in ninth. Which part? That with nitrogen, one lone pair always there. Lone pair and bond pair, they are treated as two different groups. Lone pair and bond pair are two different groups. So this nitrogen has two different groups or not? Yes, one is lone pair, one is bond pair. And this carbon has two different groups. Yes, one H, one Cl. So it is a geometrical center. Very good, Yash. Here also same. Oxygen plus means one lone pair. Bolo bhai, till 11th, any questions? Any point, any questions till 11th? Clear? All getting it? So do one thing, that today GI I will do up to this part only open chain, so that you can try these questions which are there on 309 page. Almost 5-7 questions given. Ninth is asking. Ninth question which is asking, who asking? Surya. Surya, observe. Double bond is there means restricted rotation. Then at each end, left end, I think you have no doubt. On left carbon, one H, one Cl, two different. But about nitrogen, write in the notes that nitrogen has one lone pair and one bond pair. Lone pair and bond pair, they are treated like two different groups. Lone pair and bond pair in nitrogen treated like two different groups. So here two different, there two different, and between them restricted rotation. ठीक है Surya, then same apply here. 11th, oxygen is there with plus charge. It means one lone pair is there. Done. So point is, today we are doing basic thing. Geometrical open chain. You can go through page 308, 309. You get the as per NCERT. Then your focus should be that you cover the structural isomerism from the notes, from the NCERT, from the module completely. First exercise, second, third, exemplar, all. Then you will read only GI up to this part. Because next class, I will continue from this one. Example number 12 with ring structures. Cyclohexane, cyclopentane, how GI possible. ठीक है भाई? Done. So on Saturday, I will start with that. You can ask any questions. Syllabus or test syllabus is completed already. ठीक है भाई? चलो, bye. Thank you.